Hello guys, and welcome to another video. On this video we'll be looking at how to calculate molecular mass or the molar mass. But before we get into that, let's understand the meaning of molar mass or molecular mass. The molar mass of a substance is the mass of 1 mole of that substance. Okay, so molar mass, let me just highlight there. Molar mass is the mass of 1 mole of that substance, and it is measured in grams per mole, and grams per mole is this unit here of G dot mole to the power of -1 grams per mole. And to calculate this molecular mass, we multiply the number of atoms of each element by its relative atomic mass, which is found on the periodic table, and then we will sum the totals together. We are going to be using our periodic table values for the relative atomic masses. For example, if we look at hydrogen, it would have 1, or rather the relative mass of 1, carbon would have 12, nitrogen would have 14, oxygen would have 16, sodium 23, and so forth. Okay, and I want to show you the periodic table to show you how this would work. So guys, this is our periodic table, and everything that I've highlighted in yellow is our relative atomic mass. So our relative atomic mass is the number at the bottom. As you can see, the number at the bottom of our symbol, our element symbol. In this case, we have Cu, and below Cu we have this number 63,5. That is the relative atomic mass number. So if you are going to have a situation or a question that wants you to find the relative atomic, the molecular mass, you will use the relative atomic masses, which are the numbers at the bottom of your symbols of the elements. You can see for hydrogen, the relative atomic mass number is 1. For boron, it's 11. For carbon, it's 12. For nitrogen, it's 14. Oxygen, 16. Fluorine, 19. Neon, 20. Helium, 4, and so forth. What is it for sodium? Please take a guess. It's going to be 23. What is it for magnesium? It's going to be 24. So the numbers at the bottom represent your relative atomic masses. I hope guys you got that. Now let's do a question that will help us find the molecular mass of water. How are we going to find the molecular mass of water? Firstly, we'll remember guys that this 2 at the bottom here, the subscript number, shows the number of atoms. So we look at the number of atoms and multiply that number of atoms by the relative atomic mass of that element. Let me show you how it's done. So for water, how many hydrogen atoms do I have? I have 2. So I'm going to write 2 here and multiply by the mass number of water. What is the mass number of water? It's 1. So I'm going to put 1 here, and obviously I would use my periodic table, but I don't have it close by here. However guys, you will see that the relative atomic mass number of water is 1. It's the number at the bottom. I think it will be best guys that you have your periodic table next to you as you are watching this video, okay, so that you are able to identify the relative atomic mass of all the elements that we'll be working with. And then what I'm going to do is to add, plus I have another atom, which is oxygen. How many atoms of oxygen do I have? I only have 1. Since there's no number here, it means I have 1 oxygen, and I'll multiply this one with the relative atomic mass of oxygen, which is 16, the number at the bottom of oxygen. And when I add these numbers together, I can start by multiplying to say 2 times 1. 2 times 1 will give me 2, plus 1 times 16 will give me 16. And then 2 plus 16 is going to give me 18. So my answer is going to be 18 grams per mole. I hope guys you got that. That's how we do it. Let's look at another example. Here's another example. On this example, we are looking for the molecular mass of carbon dioxide. And we firstly check if there's a number at the bottom. If there's no number at the bottom, it means we have 1 carbon. So I'm going to write that I have 1 carbon and multiply that 1 carbon by its relative atomic mass number, and the relative atomic mass number is the number at the bottom of carbon, which is 12, plus oxygen. But for oxygen, how many oxygens do I have? I have 2, so I'm going to write 2 and multiply this 2 by the number at the bottom of oxygen, which is the relative atomic mass number of oxygen, and that is 16. Then I'll say 1 times 12, and I'm going to get 12 plus 2 times 16 is going to give me 32. So it's 32, and then 32 plus 12, or 12 plus 32 gives us 44, and therefore our answer is 44 grams per mole. Remember to write the unit, guys. You must write the unit if you find yourself calculating this molecular mass. Let's go to the third example. Now we are looking for the molecular mass of sodium chloride or table salt, and the symbol is NaCl. And how are we going to do this one? We are going to check firstly how many sodiums we have. Remember, if there's no number at the bottom, it means we have one atom. So I have one sodium, and I'll multiply this sodium by its relative atomic mass, and the relative atomic mass of sodium is 23. Plus, for chlorine, how many chlorines do I have? I only have one chlorine, and then I'll multiply this one chlorine by its atomic mass number, rather relative atomic mass number, and that's going to be 35,5. 1 times 1 is 23, plus 1 times 35,5 is that 35,5. When I add these numbers together, they are going to give me 58,5. So my answer is going to be 58,5 grams per mole. You can also write it here, grams per mole. Okay, the unit. It's just that I have it here already. That's why I'm not writing it here. All right. I hope, guys, so far you are moving with me. Let's calculate the molecular mass of methane gas. Methane gas is CH4. How many carbons do I have? I have one carbon, and I multiply by the mass of carbon, which is 12, plus how many hydrogens do I have? The number at the bottom is 4, multiply by the mass of hydrogen, which is 1. Remember, we are using the numbers at the bottom of our symbols. Symbol carbon has the number 12. 1 times 12 is 12, plus 4 times 1 is 4. Then 12 plus 4 is going to be 16. And therefore, our answer is 16 grams per mole. Okay. Another example, magnesium oxide, MgO. How many magnesiums? I have one. What is the the relative atomic mass of magnesium? It's 24, plus how many oxygens? I have one oxygen. What is the mass of oxygen? It's 16. Then I say 1 times 24 plus 1 times 16. 24 plus 16 is going to be 40. So my answer is 40 grams per mole. Alright, now guys, we look at another example. This example is us finding the molecular mass of calcium carbonate or limestone. That's another name for calcium carbonate. And the first step is to check how many calciums do we have. We have one calcium. What is the molecular the relative atomic mass of calcium? It's going to be 40, plus how many carbons do we have? I have one carbon. What is the mass of carbon? It's going to be 12, plus oxygen. How many oxygens do I have? 3 oxygens. What is the mass of oxygen? It's 16. Then we say 1 times 40, that's 40 plus 1 times 12, that's 12 plus 3 times 16, that's going to be 48. And then we'll add these numbers together. 40 plus 12 plus 48 is going to give us 100. So the answer here is going to be 100 grams per mole. I hope, guys, it's making sense so far. We now move on to another example, finding the molecular mass of nitric acid. How do we do this? You see here that we have hydrogen. How many hydrogens? 1 hydrogen, and we multiply by 1 plus how many nitrogens do we have? We have 1. What is the mass of nitrogen? It's 14 plus how many oxygens do we have? 3 oxygens, and we multiply by the mass of oxygen. 1 times 1 is 1 plus 1 times 14 is 14 plus 3 times 16 is 48. And then we add these numbers together. 1 plus 14 plus 48 is going to give us 63 grams per mole. I hope, guys, by now you are getting confident, and you should be pausing the video now to answer and see if you understand. Please, once you feel confident, pause the video and try to answer on your own, just for us to see if you are understanding how this stuff is done. We'll look at aluminum oxide now. How many aluminiums do we have? We have 2. And what is the mass of aluminium? It is going to be 27 plus, what about our oxygen? We have 3 oxygens. The mass is 16. Then we'll see 2 times 27, and we get 54 plus 3 times 16 is 48. Then we say 54 plus 48 to get 102 grams per mole. Move on to question 9. Please do pause the video and try out this one. Okay, so for this one we have how many oxygens? How many potassiums? K is potassium. We have 2 multiplied by the mass of potassium, and the mass of potassium is going to be 39. And then we say plus how many sulfurs do we have? We have 1, and the mass of sulfur is 32 plus how many oxygens do we have? We have 4 oxygens, and the mass of oxygen is 16. Then we say 2 times 39, it gives us 78 plus 1 times 32 is going to be 32 plus 4 times 16 is going to be 64. Then we add all of these numbers together, and the answer we get is 174 grams per mole. And this one is the last one. Can you also try out this one? So with this one, guys, we check how many okay, this one is iron chloride, by the way. How many ions do we have? We have 1 ion. What is the mass of iron? The mass of iron is 56 plus how many chlorines do we have? We have 3 chlorines, and the mass of chlorine is 35,5. Then we say 1 times 56 to get 56 plus 3 multiplied by 35,5 is going to give us let me just check here. We get 106,5. And now we are going to see 56 plus 106,5, and the answer we get is 162,5 grams per mole. So guys, that's how you basically find your molecular mass. Okay, that's how you find your molecular mass. And remember that on the periodic table, let me just quickly show the periodic table. On the periodic table, when we do our calculations, guys, for the molecular mass, we use the numbers at the bottom. Firstly, check how many atoms you have and multiply these numbers at the bottom, which are the relative atomic mass numbers, by the number of atoms. I hope guys you understood this one, and please give me a like. See you on the next one. Bye bye.